In this video, we're going to be looking at arcs and central angles. If you find this video helpful, share, like, and subscribe. So let's look at some terminology and labeling in this lesson. So the first one is the definition of circle. The definition of circle says that it's all points equidistant from the center point of the circle. Second one is radius. Of course, we already know what a radius is, but to just define it, it is actually a segment from center to a point on a circle. The central angle, which is the main part of our lesson here, is the angle with vertex at the center of the circle. And here's the center also. Center is the middle point of the circle, and it's used to name the circle. Diameter passes through the center and begins and ends on a circle. Now the pi. The pi is actually defined as the ratio of circumference and diameter. Okay, now the symbol for pi, as we know, is actually this one. Okay, this is going to be the pi, and if we're going to do this one, this is actually the ratio of circumference and the diameter. Okay, so that's actually basically the pi. Okay, so let's look at some. Let us look at this circle in here. So the center actually is P. Okay, here's your center, this one. And the name of this circle is actually circle P. That's how we name it. Okay, remember that's the center here. This is the center. That center is going to be the same place where we're going to get the name of the circle. Another thing you're going to look at here is from segment A to B. That's actually here. This is line segment. AB is actually a diameter. Okay. Of course, we can also say that from segment PB here, line segment PB is actually a radius. Also, line segment PC. PC is also a radius. So both of them are actually the same, including also, of course, let's not forget this one, PA. PA is also a radius. It's actually half of the diameter. Now, if you're going to be looking at PBC, there is actually called an angle that is forming there. This angle. And that name of angle is angle B, P, and C. Okay, the center one. So the focus of this lesson is actually more on the central angle and the arcs of the chord. Now, in this one, let's not forget that this arc is also called from this one is actually called arc BC. Okay, so let's look at more terminologies in here. Arc. Arc is a piece or path along a circle. So very simple definition. It's just a piece or a path of a circle. The minor arc, these are actually an arc that is smaller, keyword is smaller, than, it should be than a semicircle having a size of less than 180. Adjacent arcs, these are arcs next to each other and have exactly one common point. So let's not get that incorrectly. The other word is semicircle. Semicircle is actually half of the measurement of 360, which is 180. That's going to give you half circle. Major arc are actually called larger than a semicircle, and they normally use 3 letters to label it. Congruent arcs, these are arcs with the same measure. Okay, so let's look at this circle right now in here. This circle actually is, the center is P, yeah? So we have here circle P. You have circle P, this is the center. So we're going to create a diameter here. Okay, so that's going to be line segment TR is actually a diameter. Okay, what else? Let's connect this one. Okay, so we are going to actually look at this one as line segment, PS. Okay, here we go. Line segment PS is a radius. Okay, so let's look at this one also. As a semicircle is actually half circle. So if that means this is going to be half circle, because the diameter just got 3 in it, and this is also another semicircle here. Okay. Another thing that I would like us to learn in here is what you call your major and minor arc. So we said that a minor arc is smaller than 180. So if we're going to be looking at from, let's say, this arc TS, okay, this is actually called a minor arc. It's less than 180. So let's see. There are another one here. Let's say arc TS, arc TS is actually a minor arc. Okay, it only has 2 letters to name it. Another one is this one. It's also a minor arc. It's called arc RS. RS is also a minor because they are actually less than 180. Now let's look at some major arcs. Okay, major arcs normally is greater than 180. Okay, so let's look at this part. If you are going to, let's say, I'm going to start from R, okay, from R, and I'm going to go around this one, then I will stop at C at S. This is actually called your major arc. Okay, reason this is greater than 180. So if we're going to write the major arc, it should have 3 letters. In this case, R, T, and S. So that's going to be R, T, S. This is called a major arc because they are actually greater than 180, and 180 is a semicircle. Okay, another new more terms to learn. We call it the concentric circles. So concentric circles happens when coplanar they are actually circles with the same center. So just like this example, you can see that there's one center and there's another circle and a bigger circle again and another circle. These are actually called concentric circles. Now, congruent circles. These are actually called circles with congruent radii or radius. Okay, so say for example, here the radius is, let's say, 10 centimeter. It means to say that we can only claim that this is going to be a congruent circle if the radius of the other circle is also going to be 10 centimeter. Now, let's call this circle O and this is P. So we can conclude that circle O is actually congruent with circle P because of their radius, which is having 10 centimeters. Circumference, a very common term that we always use for circle. Okay, circumference is the distance around a circle or the length of a circle. So in some other geometry lesson, you learn about quadrilaterals, which is a polygon. They actually have perimeter. So in circles, we don't have perimeter, but we have the circumference, and that is actually the distance around the circle. Like your quadrilaterals that has 4 sides that you have to measure its perimeter. In circle, we don't use perimeter, but we use the word circumference. Arc length, the last key term today. So arc length is the length of an arc along a radius, circle of a radius subtended by an angle. Okay, so in this case, the only arc length that is actually very visible in here is actually the arc AB. In this case, this one, AB, this one. So that is sometimes we are asked to compute for the arc length of this. So in our lesson, we're going to be looking at also how to compute the arc length. Okay, so let's look at some examples in here. Okay, how to name arcs and central angles. Okay, so let's look at this one. Name the arc made by the given angle. So First, let's look at the angle in here. What angle has been made in here? So here we have made this one. So that's actually going to be angle B, Q, and D. So what is the arc that's being created in here? This is the arc that's being created in here, and that's actually called your arc BC. Arc BC. Letter B. So first, let's look at the angle that has been created here. So it's angle 1 here. That's the only angle that I can see in here. Now the arc name, if I'm going to look at the arc in here, this is the arc that is created with this angle, then I can say that the arc here is called FG. Arc FG. Can you also name it as GF? Well, it's still okay with me, because anyway they are the beginning or ending of each other. Okay, name the central angle here, the central angle this time. So let's look at the central angle made by the given arc. Okay, so here the arc is RS. So if we're going to be looking at this part, that's actually arc RS. Here, the central angle that has been made is actually this angle, which is angle RQS. RQS. Okay, in letter B, let's see. We have here angle 1 only. I can see angle 1. It's actually created by this arc. This arc, which is CB. The arc CB created angle 1. Okay, let's go further. Okay, here, if an angle is given, name the arc it makes. If an arc is given, name its central angle. Okay, this is very nice. So letter A. Okay, if an angle is given, name the arc it makes. Okay, so in this case, we have angle TQS here. Angle TQS here, this part. That's the angle TQS. Okay, that is the central angle that has been created. Central angle. Created by which arc? It's created by this arc, TS. Created by arc TS. Okay, so letter B. Let's see, what is the major arc for angle EQF? Okay, here angle E, Q, and F. So where is that? E, Q, and F, this one. Okay, so we are given the angle. What's the arc this time? Let's name the arc. Okay, the arc that created the angle is actually called arc FE. Now, if you're going to take note in here, there's also another arc in here, and it's actually much bigger than the minor arc. And this arc is actually called a major arc. They are called major arc. Okay, reason they are called major arc, they are actually greater than 180. And the name of this arc that is being created is actually, there are three letters there, 1, 2, and 3. It's going to be F, G, E. Okay, so these are major arcs. How to find the measures of arcs and central angles? Okay, so let's go for this letter A. So if you're going to be looking at this one, let's label this as your Y, and this is going to be your X. Okay, so what do you think is the size of this arc X in here? So the size of this is actually the same with the measurement of your central angle. Therefore, this is going to be 130. Now, what about this specific Y in here? So this one, what do you think? So if the size of the arc, okay, subtended by this radii is going to be also the same with its central angle, which is Y is equal to 100. So the basic understanding here, always remember that central angles and arcs are actually congruent. Okay, let's go for letter B. They're asking us to find the measurement of angle CAD. CAD is this part. Now, we said earlier that the size of the arc is going to be the same with its central angle. Therefore, the central angle here is 60 degrees. If that case, this is a diameter. If you're going to be looking at diameter, it's going to create a half circle. So let me just recreate that here. So say for example that this is going to give you 60, then what's going to be a total of this? This is just going to be, remember that the whole of this is just going to be a total of 180 degrees. So in here, it's going to give me 120 by logic. It's going to give me 180 minus 60 is going to give me 120. So if we're going to find the measurement of angle CAD, then that's going to give me 180 minus 60, and it's going to give me 120 degrees. Let me just add one more information in here, that this arc CD, okay, the measurement of arc CD will also be the same as equal to 120 degrees. Reason, because earlier we said that this is going to be 120 degrees. Therefore, the arc and its central angle will have the same measurement, which is 120 degrees also. Okay, letter C. Okay, here we are asked to find the measurement of arc KJI. Arc KJI, let's mark that work. Where is it? This is going to be K, J, and I. It's quite a big one. So let's see what information has been given us at the moment. So at the moment, I can see a central angle in here, which is 155. It means to say that the measurement of arc KJ is equal to 155 degrees also, because of the central angle theorem. And also the measurement of this arc, HI is equal to 75 degrees, because it's a central angle, and it means this is also 75 degrees. So there are two unknown things that we still have to find here, and this is this x angle, and this x for us to find this arc. So now let's create our equation. So the best equation we can find is that we're going to have 155, this one, and then plus x, and then plus 75, plus x again. That's going to be a total of 360. 155 plus 75, it's going to give you 230, plus 2x is equal to 360. Then we subtract 230, that's going to give me only 2x is equal to uh, 130, and we both divided by 2. Therefore, x is equal to 65. Okay, so 1x is 65. It means to say that this is going to be 65 degrees. So in that case, if that's 65 degrees, then the arc that is being created in here is also 65 degrees. Now let's answer the question, what is the measurement of angle KJI? So to answer the question, we already found out the answer in here. So the measurement of arc KJI is equal to 155 degrees plus 65 degrees. That's going to give you 220 degrees. Okay, example 5. Solve for x in here. Assume that lines which appear to be diameters are actual diameters. Okay, so the information that has been given me is that this is a diameter, and I only need to look at this part. So I'm going to label the unknown in here as x. Here, I'm going to say x in here and x in here. But I know that one semicircle is equal to 180. So in that case, I'm going to set up my uh, equation x plus 65 in here, plus x, and then plus x is equal to 180. That's going to be 65 plus 3x is equal to 180. Therefore, 3x is equal to 180 minus 65. That's going to give you 3x is equal to 115. Divide each by 3. And our x is going to give this amount, 3.333 degrees. So that's going to be the amount of uh, or the value of x that's being asked in here. Example 6, find the measure of the arc or central angle indicated. Assume that lines which appear to be diameters are actual diameters. Okay, so let's go to letter A. They are asking us for the measurement of arc IJ, this one only, arc I and J. So what I can see is that this is a diameter. So I'm going to only get it from here, there, and there. Yeah, this is a semicircle. So having chosen that side, so what I'm gonna do is I will label these unknowns as x. This is x, x, this is also x. Okay, now I'm gonna set up my equation. We know that semicircle is only equal to 180. So I'm going to say x, then first x, plus x plus 58, plus my last x. That's going to give you 180. So that's going to give you 3x plus 58 is equal to 180. 3x is equal to 180 minus 58. 3x here is going to give you 122. Let's divide both by 3. Therefore, our value of x here is going to give you around 40.66666, and then it's going to be 7. So this is the value of our x in this case. So now to answer the question, what is the measurement of arc ij, then we're going to answer our question by adding this together, 40.667 plus 58, so that's going to give us around 98. So the measurement of arc ij in here, in this case, is going to be 40.6667. Then we add the 58 here. That's gonna give you around 98.6667. So that is the measurement of our uh, arc in here. Okay, let's go to letter B. Here we are asked to find the measurement of angle UVT. U, V, and T. But we are given the arc size in here, which is 25x. So if we're going to continue with the process, we know that a circle has a total of 360. The size of 26x minus 4 is also given in here as an additional information. So let's create our equation now with all of this. So we can say that 26x minus 4 plus 25x. Then I'm going to call this again another x. Okay. Not actually that part, but the arc here. This arc, I'm going to call this arc x. Okay. X is equal to 360. So continuing the process, 26x plus 25x plus 7, that's going to give you 52x minus 4 is equal to 360 plus 4 plus 4. Therefore, 52x is equal to 364. Okay, divide by 52. Our x is 364 divided by 52. It's gonna give us an exact number of 7. So if x is 7 and answering the question in here was the measurement of angle U, V, and T, that's going to give you 25. What's the value of x, which is 7? Okay, so that's going to give you a total of 175 degrees. Now let's recheck if our answer is correct. So here we're going to say 26 times 7 minus 4. This is going to be 25 times 7, which is we already have there, and this is equal to 7. So 26 times 7 minus 4, this is going to give you 178. Then 25 plus times 7 is going to give you 175 plus this one 7. Okay, is it equal to 360? This is a rechecking part. This is the rechecking part. So 178 plus 175 plus 7, this is going to give you 360. Okay, so this is correct. Our answer is correct in here. Practices on arcs and central angles of a circle. Here, name the arc made by the given angle. Okay, what's the name of the arc? FEQ. The angle FQE, sorry. The arc that has been made is actually arc FE. Second one, name the arc that made by the angle 1. The arc that has been created is actually this one. Okay, arc HI. Next, name the central angle of the given arc. So the arc is arc ML, the central angle is angle 1. Okay, here number 4. So arc ML, this arc ML, the angle that has been created is this one. Okay, and that's going to be LQM, angle LQM. Okay, if an angle is given, name the arc it makes. If an arc is given, name its central angle. Number 5, arc RS. Okay, RS. So we're going to be giving the angle created. That's going to be angle SQR. Okay, next. Number 6 is major arc for angle 1. So this is our angle 1 in here. This one. But they're asking us for the major arc, so we go at the back here. So this is going to be for angle 1, the arc that has been created is actually arc ACB. Okay, next. Angle KQL. KQL, this one. The arc that is being formed is arc KL. Okay, next, number 8, arc SVT. Okay, here is the arc S, V, and T. So the arc that has the angle that is being created in here is this angle. Okay, so the angle that's created is SQNT. Okay, next. Find the measure of the arc or central angle indicated. Assume that lines which appear to be diameters are actual diameters. So here in number 9, we are asked for this question mark in here. We know that we know also here that the arc is 120, and what did we say? That the size of the arc is going to be equal with its central angle. Therefore, the size of the central angle in here is going to be the same with the arc, which is 120 degrees. So in this case, just like this one, The arc size is 155, therefore the central angle that has been created is also 155 degrees. Number 10, okay, the same question again. There's a central angle equal to 123 degrees in here. Therefore, the arc of that is going to be the same measurement with the central angle, which is 123 degrees also. Number 11. So what is the measurement of arc CFD? So CFD, we'll start from here. Then we're going to go around here, F, and then we're going to go stop at D. So they're asking us to what is the size of this arc. So let's look at it on this perspective here. This is actually a semicircle from here to there. So that's going to be 180, which means that this angle in here, this one, is going to be 45. Yeah. And also this is going to be 45. So what we're going to just be including is actually this part. So we already have 180 as our first size in here. So from here to here, that's actually 180. Then we're going to add 45 and 81. 45 and 81. So if we're going to now write this one, our answer in here, the measurement of arc CFD is going to be equal to this one, 180, the semicircle, plus 45 plus 81. So that's going to give you a 180 plus 45 plus, here this is 81, plus 81, it's going to actually give us 306 degrees. Okay. Okay, number 12. We are asked to find the measurement of angle SPQ. So let's look at where is SPQ. S, P, and Q. It means to say that this is this angle. So let's look at what are the given in here. So we have 86, we have 154, we have 60. This arc, I don't know the size of this arc, TS. So I'm going to call that as X. And they're going to call that as X in short. Okay. So we know that a whole circle is equal to 360. So let's add everything starting from arc. Let's say here, we're going to say the size of arc UQ, UQ plus QR, arc QR, plus R arc RS, okay, arc RS, and then we're going to arc TS, and then plus TU, arc TU. So that's going to give you a total of 360. Okay, so let's look at this one. Okay, so let's see. Our UQ is going to be 86 degrees plus 154 degrees plus our RS is 60. Now TS is we don't know, so we just put it as X and then X in here. So that's going to give us 360. 86 plus 154 plus 60 is gonna give you an exactly 300 degrees plus X and X is going to give you 2X. So therefore, if I'm going to subtract 300 from 360, it's just going to give me 60 is equal to 2X dividing by 2 divided by 2. So that's X is going to give you 30 only. It means to say that the size of this is going to be 30. Now, since we already know that one, therefore we can now answer the question in here. What is the measurement of your angle SPQ? Now, S, P, and Q, this one. So we're going to be looking at this one. With all of this right now, we can say that the measurement of angle S, P, and Q is going to be, we're going to look at the arc. The total arc in here is going to be 86. Okay, let's look at that one. 86 degrees plus 30 plus 30. Okay, so 30 plus 30 is going to give you 60. 86 plus 60 is going to give you 146 degrees. Okay, that's the final answer to that. Okay, let's go to the next item. Here we are being asked to find the measurement of arc EFC. So let's mark that part. So where is our EFC in here? So our EFC is actually starting from here, E, F, and then C. It means to say it goes this way. Okay, so what can we find in here? So this is a semicircle. Okay, if you're going to find this one, this is actually a semicircle. So the size of the other angle in here, since this is a semicircle is equal to 54. It means to say that this angle 126 minus, so we subtract 126 from 180, and that's going to actually give us a total of 54. So this is 54. Now look at this one. If you're going to be, I would like you to observe this one because this line segment BE and line segment CF are both diameters. So since they are both diameters, it means to say that the angles that are formed are going to be congruent. That means that we are going to also have 54 degrees in here. They are congruent angles actually. So now I guess we have taken everything already. That's all that we needed. EFC, arc EFC. So here the measurement of arc EFC is going to be starting from the arc of EF plus the arc FB plus the arc BC. Okay, which is now here your EF is going to be 54, your FB is 126, and then plus 54. So 126 plus 54 plus 54 is actually going to give you 234 degrees. So that's how you're going to find it. Okay, let's go for number 14. In here, we are asked to find the measurement of angle MIJ. So let's find that out. Where is that angle MIJ? So here, M, I, and J. It means to say that this one. Okay, remember that the size of this central angle will be the same with the size of this arc also. So just like this one, you can see actually in here the size of the arc. Here, this is 55. It means to say that this angle is also 55. Now, also remember, I would like you to take note of this, that line segment JL and line segment MK are both diameters and they are intersecting to each other. It means to say that the central angles that are going to be creating are congruent to each other. So with that said, we can also list it if you like. We can list it this way. We can say that arc MJ, okay, let's start with the diameter. So line segment JL, okay, is congruent with line segment KM. Okay, they are both diameters. What else can we find that? It means to say that arc JK, here, this one, the arc JK will be congruent with the arc ML, which is equal to 55 degrees. Also, we can say that the measurement of angle MIJ, okay, if I can say that, MIJ, MIJ should be congruent with angle L, uh, here, this one, uh, LIK, angle LIK, which is still unknown. So let's find that out. Okay, so let's find it out. So this is 55 degrees. That's 55. It means to say this is also 55. So we have 55 plus 55. And then we're going to call this x and then another x again in there. So that's going to give you x plus x is equal to 360. 55 plus 55 is going to give you 110 plus 2x is equal to 360. 2x is equal to 360 minus 110. So that's going to give you 250. Yeah, 250 divided each by 2. Therefore, the value of x here is going to be 200 and, no, not 250. It's going to be half of 250 is 125 degrees. Now, having said that, therefore, we can now answer what is asked in here. What is the measurement of angle MIJ? So we found out that this angle is going to give you 125, and this arc is also the same as 125. The opposite angle, a central angle, is also 125, and this arc will also be 125. Okay, so this is now going to give you 125 degrees. That is the answer to this question. Okay, so the next thing in here is solve for x. Assume that lines which appear to be diameter are actual diameters. Let's look at number 15. This is very interesting. Okay, so we have seen in here that there are two diameters intersecting each other, and so they are forming equivalent, or we call it congruent, central angles and congruent arcs. Okay, it means to say that the size of this arc in here is also going to be 6x minus 8. Now we are also given an information in here that the other arc in here, this arc is going to be 140 because the central angle in here is going to be 140. So in conclusion, the other opposite angle of this will also be 140, and as much as this arc is going to be also 140 degrees. Now they are asking us what's the value of x. So let's look at it in this perspective. I'm going to get this part. Okay, that this is a semicircle and it's going to be a total of 180 degrees. Okay, having said that, so we're going to create an equation now. So that's going to give you 6x minus 8 plus 140 is equal to 180 because that's a semicircle. Okay, 6x is equal to 180 minus 140 plus 8. 6x is equal to 180. 180 minus 140 is going to give you 40. Then plus 8, it's going to give you 48. Divide both by 6. X is equal to 48. 48 divided by 6 is going to give you 8. Okay, so therefore, the value of x in here is going to be 8. Now, this is not our final answer. The final answer is that we're going to see whether these two are actually the same. Actually, it's all the same. 6 times 8, here 6 times 8 minus 8 is going to give you 48 minus 8 is going to give you 40. And this is also going to be, this part is also going to be 40. Now let's try to recheck. Okay, so that's going to be 40 plus 40. That's going to give you 80, and then plus 140, and then another 140. That should give you a total of 360. So our answer here is correct. Okay, number 16. So let's look at this one. This is very interesting. Okay, so let's look at it. So what we can notice in here is that there is a semicircle that I can see. There is one diameter in here, this part, and they're asking us to find the value of x in here. That's all that we can see. So as far as naked eye can see, I can say that this is a 90 degree. Okay, so let's create our equation here right now. So the first one is going to be 90 plus x plus 93 is equal to 180. 90 plus 93 is going to give you 183 plus x is equal to 180. Therefore, my x here is going to be 180 minus 183, and the value of x here is just going to be negative 3. Now, let's recheck it. If this is going to be negative 3 plus 93, then it's going to give you 90 degrees. Yeah, it means to say that this is 90 degrees and that's 90 degrees. It means to say it's going to be correct because this is a semicircle and a semicircle has only a total of 180 degrees. Okay, so next, let's find the measure of the arc or central angle indicated. Assume that lines which appears to be diameters are actual diameters. Okay, number 17, let's look at this one. We are asked to actually find the measurement of arc WV. Okay, I guess this is quite easy. This one only. We're asked. So what I can see in here is that line segment SV is a diameter. So if we're going to connect this one, 12x minus 2, size of this arc of this circle, that's going to give you a total of 180. Instead of that, we're going to create our equation. So 180, so let's say that we're going to give you, this is going to give us a total of, let's say, 12x minus 2. Okay, let's call this one again x for easier way to solve. Okay, it's a total of 180 because 180 is the size of a semicircle. Now 12x plus x is going to give you 13x minus 2 is equal to 180. 13x now is equal to, transpose this on the other side, that's going to give you 182 divided by 13. Okay, 182 divided by 13 is going to give you a total of 14. So this is going to be 14. Okay, so having said that, then we can just actually recheck if we are correct. So let's say the measurement of WV, arc WV, is now going to give you 180, okay, minus this one, this amount. Let's put in the value of 14 here. So 12 times 14, okay, 12 times 14 is going to give you 168 minus 2. Okay, so that's going to give you 166, okay? So this is going to give you 166. 180 minus 166 is going to give you 14 degrees. This confirms with our answer in here. Okay, so this is all for these lessons on arcs and central angles. If you find this video helpful, share, like, and subscribe. Thank you very much.